For this question, we are supposed to find the range of values of a, for which ax squared plus 3x plus a is always negative. So the fact that when it's always negative, right, we are talking about, imagine that this is a y function, this is a function, right? And if we want this to be always negative, it means that we want so-called the y value, right, to be always negative. So imagine that if we let this to be y and we want this function to be always negative, what we are looking for is that, imagine the graph will be underneath the x-axis. Okay, it will be underneath the x-axis. So this will suggest that your graph, right, has to be always underneath the x-axis, because only when the graph is like this, right, it will always be negative. Okay, so for it to be always negative, you know that it cannot be a U shape. It has to be an N shape. Okay, this will suggest to you that the coefficient of x squared has to be less than 0, meaning in this case, your a has to be negative. Okay, in order for your graph to be always negative means that it's always underneath the x-axis, because we are talking about the y value to be always negative. Okay, at the same time, you notice that this will not touch the x-axis. Okay, because if it touches the x-axis, it will not be always negative anymore. It can be 0. Okay, 0 is not negative, so the y value cannot even be 0. It has to be always less than 0. Okay, so this right here always means that the y value is always less than 0, meaning that it always lies under, the graph always lies under the x-axis. Okay, so with that, we established two conditions. First one is that the discriminant has to be less than 0. Second is the coefficient of x squared has to be less than 0. Okay, so we set our discriminant over here. This is my a is 1, my b is 3, and my c is a. Right, so my discriminant is equals to b squared minus 4ac, and you want this to be less than 0, meaning you have 9 minus 4a squared less than 0. Okay, so to be careful, we don't want you to square root both sides. Never ever go into the extent where you do something like this out there. So a common mistake made by most students is they do this, right? And then they actually go and square plus minus 3 over 2. And then after you get confused, is it plus or is it minus? Or can you leave the answer like that? All right. So remember that when we are doing this, we never ever square root both sides. Okay, because as I've told you before, this is a mistake. Okay. So from here, simply factorize a squared minus b squared, a minus b, a plus b. Okay. So what am I using is I'm using the algebraic identity. Okay, when you factorize a minus b, a plus b, this is equals to a squared minus b squared. Okay, so from here, we have our algebraic expression factorized. Okay, after which we draw the curve out. So remember, this represents the curve of the function. Okay, so over here, now with this function here, I'm drawing another curve. It's not for the function, it's for this particular discriminant. Okay, so I'm going to draw the curve that represents this discriminant here. Okay, and the discriminant expression basically is 3 minus 2a, 3 plus 2a. Okay, I'm going to sketch this out. The curve there, this is basically different. This is the curve that represents y equals to ax squared plus 3x plus a. Okay, there are two very different curves. Do not be confused by the two of them. Okay, so 3 minus 2a, 3 plus 2a, it will probably look something like that. So you know that the coefficient of a squared is negative, so it will look something like this. Okay, okay, and from here, you know that the intercepts, the x-intercepts basically will be equals to negative 3 over 2 and also 3 over 2. Okay, because if you put, for example, 3 plus 2a equals to 0, you know that a is equals to negative 3 over 2. Okay, similarly from here, if 3 minus 2a equals to 0, then a is equals to 3 over 2. So this is like the a-axis, which is horizontal axis. Then 3 over 2 will be here, negative 3 over 2 will be here. Now you are looking for the values of a that will give you the y value to be negative. So it's basically this portion here, right? So solving the discriminant less than 0 enables you to get a less than negative 3/2, or not n, or a more than 3/2. At the same time, you also must take into consideration that you need the coefficient x squared to be negative, therefore a as well. So if you combine all these three, right, 1, 2, 3, right, if you want this both to happen, now these two either one, this and this, right, basically, if you want a to be less than 0, then let me just draw the number line. Okay, so first of all, negative 3/2, I want this. I also want 3/2, a to be more than 3/2. Right, this portion here, a must be less than 0. So 0 is somewhere in between. Right, it must be somewhere in between. Okay, so if we look at this, right, the intersection of the first and the second, you can see that there is only one section here that encompass, right, the intersection of both sets, okay, which is a to be less than equals to, sorry, less than, not less than equal, less than negative 3/2. Okay,